Hello. So on page 491, it says refer to the following figure. It says refer to the following figure which indicates radian measure on the unit circle for angles in standard position. And then for exercises 27 to 30, use the figure to determine whether the given quantity is positive or negative. And then for numbers 31 through 36, use the figure to determine which of the given quantities is larger. So if the whole circle is 2 pi radians, 2 times pi, if pi is 3.14, this is 6.28 about. It's about 6.28 all the way around the circle. So this is going to be almost 6.5, almost 6.5, 6.25. So 1 radian is about here, 2 radians, 3 radians, 4, 5, and 6 radians. So we're looking at sine of 4. There's no degree symbol, so this is radians. Sine of 4, well, there's 4. So sine of 4 is definitely negative. 20. So for 27 through 30, we're just looking at positive or negative. Okay. So sine of 4, 4 is when y is negative. This is negative. Cosine of 4 is the x value. X is negative in quadrant 3. This one's negative. Tangent of 4. Tangent is sine over cosine. So we have negative over negative. That's positive. Sine of 1 plus sine of 6. So sine of 1 is like about 0.85. Sine of 6 is like negative 1/2. So 8 minus 1/2 is a positive number. If we have this much height, which is your y value, plus, or actually this much height minus this little bit of negative y value, you're going to end up with a positive amount. So that's going to be positive. How about sine of 1 minus sine of 6? So sine of 1 is this much height. This much height. Taking away this little bit of negative, you're going to have a positive number. Sine of 1 minus sine of 6 is the same thing as sine of 1 plus minus sine of 6. You'll get a positive value. Sine of 5 or sine of 6, which one is bigger? Sine of 5 looks like a negative 0.8. Sine of 6 is negative 1/2. So this is bigger. Sine of 6 is bigger. It's higher up. What's bigger? Cosine of 3 or cosine of 4? Cosine of 4. Cosine of 4 is like negative negative half, and cosine of 3 is like negative 0.9. So 4 is closer to the x-axis. 4 is bigger. So tangent of 4 times tangent of 5, or tangent of 5 times tangent of 6. So here I'll look at algebraic signs. Tangent 4, tangent 5. So tangent of 4 is positive. Negative over negative is a positive. And 5 is negative because sine is negative, Cosine is positive here. Your y is negative and your x is positive. So we have a negative sign times a positive sign. I'm sorry, I got this backwards. A positive sign times a negative sign. So this would be something positive times something negative. So now tangent 5, tangent 6. Tangent 5 is negative and tangent 6 is negative. Your y value is negative in both of these and your x value is positive in both of these. So you have a negative times a negative. So a negative times a negative is a positive, and this product will be a negative. And so this one is bigger. Okay. So here I'm going to let the point xy denote the point where the terminal side of angle theta in standard position meets the unit circle, and use the given information to evaluate the 6 trigonometric functions of theta. Okay, so what they're asking for here is for problem 60, it's going to end up in quadrant 4, and our x is 1/3. And from that information, we need to find all of these 6 points. And these are actually, these are a lot of fun. I like these a lot. So quadrant 4, be somewhere down in here. The x is 1/3. So notice x is positive. X is 1/3 means that 1, 3. This is supposed to be a right angle, even though it doesn't look like it. So if that's a right triangle and we're just missing our y value, let's do the Pythagorean theorem. So we have a squared plus b squared equals c squared. So we have y squared equals 8. That y means we have a 2 radical 2, and since I'm in quadrant 4, this will be negative. So now we can solve the rest of them. So sine is going to be negative root 8, which is negative 2 radical 2, divided by the hypotenuse. Cosine, tangent is sine over cosine, divided by 1, doesn't matter. Cosecant is the inverse. Rationalize the denominator. We get negative. There's a 4 in the denominator. There's 2. Yes. Secant is going to be 3. And cotangent is going to be 1 over this. Rationalize the denominator. And we get okay. Here we're quadrant 1, and x is 3 over 5. Just some type of a triangle. And if my x is 3 over 5, 3, 5. Okay, what's our missing side? it's 4. So then sine is cosine. Tangent is sine over cosine. Cosecant is the inverse of sine. Secant is the inverse of cosine. And cotangent is the inverse of tangent. Okay. Here we're in quadrant 3, and y is negative 5 over 13. Quadrant 3 is down in here. So we have negative 5 over 13. And this will be negative 12, because 5 squared plus 12 squared is 13 squared. So now the sine is your x, sine is your y. So we have negative 5 over 13. Cosine is negative 12 over 13. Tangent is sine over cosine. Negative over negative is a positive. The 13s simplify. Cosecant is the inverse of sine. Secant is the inverse of cosine. And cotangent is the inverse of tangent. Here we're going to end up in quadrant 2. Y is 3 over 4. Okay. What's the missing side length? Well, we have 16 minus 9, 7. It's going to be negative because cosine is negative in this direction. So sine is 3 over 4. Cosine is negative 7 over 4. Then tangent is sine over cosine. Rationalize the denominator. Cosecant is the inverse of sine. Secant is the inverse of cosine. Rationalize the denominator. And cotangent is the inverse of tangent. So this is going to be so here we have when theta is in between pi and 3 pi over 2. This is going to be in quadrant 3. And x is negative in quadrant 3. And we have negative 8 to 15. So this negative 8 in the x direction, 15 is our hypotenuse. And using Pythagorean theorem, we find that we have, I can leave off that negative for the negative 8 because when you square it, it goes away. So this is 225 minus 64. 161. Is this a prime number? Well, let's take a look. So 161 is between these values. So then you would take the square root of all of them. And then we're going to find the prime factors up to this smaller number. So we're going to look at 2, 3. We don't need 4 because we already did 2. 5, 7, and 11. And test all of these numbers if they divide evenly into 161. If they do not, then this is a prime number. So 2 does not divide into it because 2 is an even number. 3, 6, 7, 8 does not. 5 does not. It does divide from 7. So 161 is 7 times 23. 23 is a prime number, and so is 7. So this cannot be simplified. And this will be negative because it's the y value in quadrant 3. So that sign is cosine was given. Tangent is sine over cosine. A negative divided by a negative is a positive. Cosecant is the inverse of sine. So this will end up being secant secant is the inverse of cosine, and cotangent is the inverse of tangent, which will become, when you rationalize the denominator, that's what's going to happen. Okay. Thank you very much. Please go to tutoring.